This is part 3 of looking at this paper on stability and transmissibility of COVID in the environment. It is a very good paper, so it's worth going slow on this. Picking up where we left off, COVID has been shown to remain on skin samples. This is using porcine skin samples for 8 hours at body temperature. And if it's colder than body temperature, so at 22 degrees Celsius, it can last up to 96 hours on skin. And if the skin is cooled, this would never happen, but if you were at 4 degrees Celsius, it would be 14 days. And this other study looked at COVID and influenza on the skin. So COVID can survive approximately 9 hours on skin, which is way longer than any influenza can, because influenza, the flu, can only last about 1.8 hours on the skin, showing that the stability of COVID is very, very high. Again, COVID is not like the flu whatsoever. This is all to underpin the importance of hand hygiene. Wash your hands. Now, COVID can remain viable on solid surfaces such as plastic, glass, stainless steel, and polymers. On stainless steel, so this could be like a cooking environment, COVID could still be found at low titers after 4 days and at high titers at 7 days. So this is a lower starting dose, higher starting dose. So the more COVID there is in the droplet, the longer it can last on the surface, underpinning that you need to be wiping down your counters. So COVID poses a much higher risk of transmission through fomites than influenza does, than the flu does. And food is a particularly good way, especially cold food, for COVID to survive long periods of time. Under refrigeration, 4 degrees Celsius, and freezing, -10 to -80 degrees Celsius, the virus can remain infectious for more than 21 days in some foods, which is very important here in the green because under globalized logistic networks, so this is basically our food distribution system, foods are imported and exported cold at a low temperature, so this is a very high likelihood method from which COVID can be transported or exported from one country or region to another within a few days, meaning that contaminated food could be a vector for international transmission of COVID. And then you can pause this real quick, so I'll turn it this way. There we go. So in general, COVID can survive longer on hydrophobic, less absorbent surfaces. COVID inactivates more rapidly. It dies off more actively on porous surfaces. So this is something that has holes on it. And COVID can survive even longer if there's a protein source that it can live on. So in meat, this would be a great way for COVID to survive long periods of time, especially frozen. Like any other virus, viruses are sensitive to temperature, so COVID is sensitive to temperature, so heating is one method used to inactivate COVID. So this should be done with an oven versus microwave. And don't share drinks with other people. Water cups are the most frequently contaminated site in hospital rooms, and COVID can be detected in water cups at room temperature environments for 2 days after the infected patient has left the room, suggesting that water cups play an important role in viral persistence. I'm not going to go over the humidity and temperature relation with COVID survival. I have a calculator that I shared in a couple of videos back, so you can use that to get a sense of it. But in general, there's a U-shaped distribution of increased temperature and humidity. And something that has confused a lot of people is this right here. So conventional epidemiologic studies cannot distinguish between competing transmission pathways. For example, if you're in a room with a person and you're sharing a meal and you can't really determine if it's from the direct transmission of inhaling the respiratory drops versus the indirect transmission of eating the food that is now contaminated with COVID. So all this means is that it's hard to control for. It does not mean that fomite transmission does not exist. Now, the most convincing evidence I've seen so far is in September 2020, an outbreak occurred amongst dock workers in Shandong province, where there was no epidemiologic evidence of exposure to any COVID cases, but they did find COVID on the outer packaging of frozen cod, to which the workers were exposed, indicating that this outbreak was generated from the frozen meat itself, demonstrating that cold food in their packaging can serve as vectors for reintroduction of COVID into areas where transmission was initially controlled. So importantly, there is now extensive evidence supporting the contamination of surfaces and objects caused by individuals infected with COVID, and also showing that COVID has a high stability and viability in the environment. Depending on the surface it's on, the temperature and humidity of that COVID is experiencing, it can survive from hours to days and experimental animal models have proved that infections can occur via fomite transmission, where we have direct evidence in China where COVID outbreaks have been caused through imported cold chain foods. And the authors recommend that a very important measure that needs to be taken is strengthening the inspection and quarantine of cold chain foods from high epidemic areas as an effective measure for COVID-19 prevention. And then PPM, personal protective measures, including hand washing and regular disinfection practices, should reduce environmental contamination and the possibility of environmental transmission of the virus.